So let's introduce some matrix row operations. Now, as we continue to proceed with understanding how to solve matrices, our goal is to rewrite through our manipulations that we're learning into some type of a matrix that has ones on the diagonal. To the left of the ones are zeros, and to the right of those are some constants or some coefficients. And so if we get a matrix down to this form, then we're able to look and view the solutions within that. So we're going to introduce to you some matrix row operations. And there's three types of operations. The first one suggests that I could flip and rotate or switch around any two rows. So maybe I have row 1, I could change it with row 2 and just reverse them. That's one operation that we can use. Another one is that I can take any row and multiply it or scale it by a constant, ideally other than 0. And the third one is that I can use a little bit of the addition method that we've learned before, is where I can multiply one row by a constant, add it to another row, and then take those combined and create a new row. So that's something that we can look at doing. So let's look at an example of how this really plays out. Let's look at an example right here of how we can use some row operations to manipulate or modify our original matrix. Now remember, all a matrix is just a system of equations, but without the variables. We're just looking at the coefficients. And our goal, again, why we're learning these is because we want to use those strategically so we can build a matrix such that our ones are on the diagonal. So let's just try an example. Let's see what this rotation looks like. I want to do row 1 and exchange it with row 2. So what would that look like? Well, let's take our augmented matrix here, and let's just rewrite it. So row 2 now is row 1. Row 1 is now row 2. So that's a use of that one type of an idea of how we just interchange two particular rows. All right, let's look at another one off this original matrix. Let's scale a row. Scale a row means take some constant and multiply it through that particular row. So let's look at 1/3 of row 1, and let's scale that. So let's go back into the one that we're working off of, and everything in row 1, we're going to scale it by 1/3, which means we're dividing each number by 1/3. So 1/3 of 3 is a 1. 1/3 of 18 is a 6. 1/3 of -12 is -4. 1/3 of 21 is a 7. Not asked to do anything with the other two rows, so those just become as they originally were. I hope that you can appreciate this 1/3 multiplying all the way through. That's basically whatever I do to one side of an equation is good as long as I do it to the other side. And so that we're usually basically using the multiplication property of equations where we multiply both sides by a particular constant. So that's really all that is. One more example to show us is, let's look at a little modification of that, where we modify one row and add it to another row. And that's the row we replace. Kind of a little bit of the addition property. So I'm not doing anything with row 1. So I'll leave row 1 the same. Whoops, sorry, up there is 3. Row 2, not really doing anything to row 2. And I'll tell you why. I might have communicated that we were. Okay, but it's row 3 that we're changing. This notation tells me that I'm going to modify row 2 by a factor of 2, then add it to row 3 and replace row 3. So let's try to do this a little bit to kind of keep track of what's going on. So I'm going to take 2 times everything in row 2. So 2 times a 1, or 2 times a 1, then add it to here. And maybe up here is the best way to do that. So let's look at, I'm going to multiply everything here by a 2, then add to row 3. So 2 times a 1 is a 2. 2 plus -2 is a 0. So then I would have a 0 in that first spot. 2 times a 2 here is a 4. 4 plus a negative 3 is a positive 1. 2 times a negative 3 produces a negative 6. Negative 6 plus a 4 makes a negative 2. 2 times the 5 is a 10. 10 plus the negative 6 makes a positive 4. So there's my new matrix. Well, not a new matrix, but the matrix based off of this row operation. Now this one can be a little confusing at first until you do some practice. What it's suggesting that I take 2 times everything in row 2 and add it to everything in row 3 to create a new row 3. So I hope that was helpful as a little bit of a demonstration of some of the different row operations we can do, because if we can learn to do these in a strategic way, we're going to be able to get to our matrix that we're shooting for.